So today we are going to solve a neat matrix problem from Leetcode, and that is equal sum grid partition that we have see in the today contest of weekly contest 2449, right? And the question is saying that this question is equal sum grid partition 1, and it's a Leetcode 3546. So previously in the last video we were seeing 3545 question. This is 46 problem. So let's understand. So what we have given here, right? Just pause this video and go through the statement so you will understand clearly. Okay, let me continue this video. So you have given n cross m matrix that is called grid of positive integers, as you can see in the example, and your task is to determine if it is possible to make either one horizontal or one vertical cut on the grid such that each of the two resulting sections formed by the cut is non-empty. The sum of the element in both sections is equal, so return true if such a partition exists, otherwise return false. So in the example 1 we have given 1 4 and 2 3, right? It means this 1 4 2 3, right? So what we have given, you are given a 2D grid of positive integers. As you can see, these are positive values, right? And your goal is very simple. So can you cut this grid in a half horizontally, or you can cut by vertically, right? So that both parts have the same total sum. So if you do 1 plus 4 is 5, 2 plus 3 is 5, means both parts is same. If you do the sum like vertically, it will not be equal. It will become 1 plus 2 is 3, 4 plus 3 is 7. That is not equal, and that is why we cut this horizontally, right? Means both part, this part sum and this part sum should be equal. If yes, return true. If not, return false. And so in this example we are returning true because we can cut by half, and if you make the sum of this part and this part is equal. I hope you understand the question, right? You understand the you can say given problem, right? So understand the intuition now, right? So how do we approach this problem? We start by understanding one thing. So if the total sum of the grid is odd, we can't split it evenly, right? So the step 1 is get the total sum, right? So if the total sum of the grid is odd, we can't split it, right, evenly, right? So what we can do, right, we will go to the, let's suppose in step 1 to get the total sum. Okay, so we can scan row by row, right? Let's suppose for this previous one, if you do the sum, 1 plus 4 is what? 5. 5 and 2 is 7. 7 and 3 is 10. Means we can split it evenly. If we'll do half, simple, 10 by 2, right? 10 by 2 is what? 5. Means we can do half. That is possible. Let's suppose it's coming 11. Then how will you do that? Not horizontal, not vertically, right? That is not possible. So in the intuition, what you should understand that, right? How do we approach this problem, right? So we should start by understanding one thing, right? What if the total sum of the grid is odd, right? We can't split it in the half, right? So the step 1 is to get the total sum of the given grid elements, right? Then we can scan row by row and we'll check if a horizontal cut we can do or not. So somewhere in the between the rows, right, gives a top part, so sum is equal to half, that we have seen just now, right? And so like if that doesn't work, right, we try vertical cuts, right, by computing the sum of each columns, and we'll check prefix from left to right, right. Let's suppose we'll go from here to here, then we'll check from here to here, like that we can go and we'll check. Okay, so just think about, just pause this video here and just understand the intuition I have written very clearly, that if we have given grid 2D, what we have given a 2D grid of positive integers, and the goal is to determine if it is possible to make exactly one cut, either horizontal or vertical, right. So both resulting section are non-empty, so the sum of element in both parts should be equal, right. Then we have to approach what? Calculate the total sum of the element in the grid and iterate through the row and columns to compute the prefix sum. You know the prefix sum, right? Prefix sum is very important. If you have not gone through, go and see my playlist where you can see the FAANG preparation, right? And so I have created a 6-month 180 days FAANG preparation guide where I have put this video of the prefix sum. So basics of all the questions are coming. So I have almost uploaded 10 to 12 videos. You can see from there, right? So how to do that? The prefix sum. Sorry, let's continue this one. So the approach is calculate the total sum of the element in the grid, iterate through row and columns to compute their prefix sum, and then check if any prefix sum equal or half of the total sum, right? So if a prefix exists, a valid equal partitions is possible, right? Means first of all calculate the total sum of the element, right? Why? Because we can check if the sum is coming or we cannot do anything. We just return that. If it is coming even, right, then iterate through the row and column to compute the prefix sum, and then check if any prefix sum is equal half of the total sum. We'll check, right? Keep checking, right? And if such a prefix exists, the valid equal partition is possible, right? So if you talk about the algorithm, right? If you talk about the algorithm, then what we can do? We will compute the total sum of the element in the grid, right? Then we'll check the horizontal cut. For each row except the last, maintain a cumulative sum. If this cumulative sum equal to total sum by 2, then we'll return 2. Otherwise, we'll if this is happening true, right, then what we will do? We'll check the vertical cuts. First, compute the sum of each columns, then check prefix sum of columns for equality with the total sum by 2. If no such cut is found, return false, right? So what we can do, let's suppose I'm trying to explain again here, so you will understand the approach, right? So let's suppose we have given 1, 4, 2 and 3, right? So in the first cell we have what? 1, 4, right? And then 2, 3. So in the array, if you see what we have given, 1, 4, 2, 3, right? And so we have represented like this. Okay. So if you do total sum, it is become what? 10. 1 plus 4 plus 2 plus 3 is 10. Total sum is 10. So after cutting between rows, right? Let's first from here to here is what? 1 plus 4. So the sum is what? 5, right? In the bottom part, if you'll do the sum is 5. And so we return equal is 2. Let's suppose the 1 and 4 is not here. We have 3 here. 1 and 3, right? So and this will become what? 2 and 4, let's suppose, right? 1, 3 and 2, 4. Just think, okay? So the total sum is still 10, right? But try and cut. You don't get the equal parts because this is 3, right? 1, 3 is what? 4. And here 2, 4. This is 4, right? So 2, 4 is 6, right? So above it is coming 3 and down it is coming what? 6. Means we are not able to get equal parts. So we'll return false. So just don't assume that the sum will make you feel that we can do the cut, right? And that is why compute the total sum of the element in the grid, but we have to check the horizontal cuts and the vertical cuts. I hope you understand, right? So first example that we have given is 1, 4, 2, 3. You put in the grid. Another just take what I told you, 1, 3 and 2, 4, right? Yes. So if you look in the second example, 1, 3, 2, 4, if you write, right, you cannot cut in equal parts. and so we have to return the false. But in the first example, 1 4 2 3 was there, so you can cut the half and you will get 5 5, right? In both in horizontal and in the horizontal cuts, right? So for the check, how will you check the horizontal cut? So for each row except the last one, maintain a cumulative sum, means 1 plus 4 is become what? 5. And if the cumulative sum equal to the total sum, what is the total sum? 10 by 2 is equal, return true. Similarly, check for the vertical one, means how will you check? First compute the sum of each columns, right? Column 1 and column 2, right? You check, okay, and then check the prefix sum of equal total sum by 2. If it is happening, return true, otherwise no such form is there. Let's suppose the vertical one. So if we'll do 1 plus 2, it is coming 3 and it is coming 7, and that is not possible, right? So only vertical, only in this case horizontal is cut is returning the value. So no need to check the vertical. So first check the horizontal. If it is not having, then check the vertical one. Okay. So let's understand the pseudocode. Then if you talk about how we'll write the function, right? So the Leetcode, you will see we have given the grid one, right? And then what we will do first, we'll check m number of rows. We'll take the some variables. M is number of rows, n is number of columns. Then then what we will do, we'll do total sum. As I told you, sum of all the elements in the grid. Once you have the total sum, then what we will do, now we will find the prefix sum, right? Row of the prefix sum, right? So for prefix sum, what we have to go, we have to go from 0 to m minus 2, means the last 2 column, right? Last column. Then what we will do, we'll go for we'll compute the prefix sum. Each element it will come, and we'll keep computing. If prefix sum into 2 is equal to total sum, or total sum by 2 you do, right, it will return true, means the horizontal cut is possible. Otherwise check for the vertical. Then you have to define the call sum array of length, and you will go for the j 0 to n minus 1 in this case, and for that you have to go for the I for 0 to m minus 1, or you have to go to the column also, right? Then you will find the column at j plus equal to grid at ij, right? You will get the value. Then similarly column prefix you will find, you will go for the 0 to n minus 2, you will find the column prefix equal to plus, you keep adding the value, and if it is multiply or divide by total sum, you will do total sum by 2 you will do, or either column prefix into 2, you will have the answer. If it is equal, then return true, otherwise not the horizontal cut is there, not the vertical cut is there. We can't do anything, just return false. Okay. So try and cut, you won't get equal parts, then return just false. Otherwise, if it is horizontal cut, you will return true. If it is vertical, you will return true, right? Let's go to see the code. See the problem, right? You pause this video and go through the statement, and also go through both of the example that we have seen. So 1 4 2 3 we have already seen, and this was we have talked 1 3 2 4, in which we are returning false because that is not able to cut it, right? Let's understand the code part, right? So what we have in the code, now let me zoom little bit, right? So as I told you, first of all find the number of rows, right? Then find the number of columns, right? Then calculate the total sum. How will you get the total sum? Go through the grid, right? You will get all the rows. For now you traverse the rows, you find the each element value and keep adding onto the total sum. So your total sum is ready. Okay. In the step 2, try to check the horizontal cuts, right? How will you do? Row prefix sum you will find, and for that you must cut the 2 parts. So for that, what you will do, you have to go 0 to m minus 1, right? And for that you will check j 0 to n, and you keep adding the value into the prefix sum. Now your prefix sum is ready, right? Now just check either total sum by 2 or row prefix sum into 2 is both are equal, return true, or either this will go divide by 2, right? Either multiply or divide. Similarly, you have to check for the column sum. You find the column sum like this, go for the all the elements, right? And then you will have the column sum. Similarly, you will find the try vertical cuts, and for that you will have the column prefix sum. You will go for the 0 to n minus 1. Cut must leave both parts non-empty, and for that you will keep adding all the column values into the column prefix sum. Once the prefix sum is ready, just check with the total sum. If it is equal, return true, otherwise return false, right? Find the m and n row and column, then go for the step 1 where you have to calculate the total sum of all the elements in the grid. Then you check the try cut the horizontal cuts between the rows, then try to prepare for the column wise sum, and then try to check the vertical cuts. So horizontal cut and vertical cut, you try this, right? And if that is not possible, then just return the false. For the solution, so we have n and m, right? Number of rows and columns we have, let's suppose. So m into n is the total number of elements in the grid, right? So if you talk about the constant, right? So we are told that it should be less than equal to 10 to the power 5, right? So time complexity will become the total sum calculation. If we'll do, we are visiting each element, right? So for all the element m into n, so O of t means O of n times will go, and for the horizontal cuts, right, we are going for up to m minus 1 row, and we sum all the columns. Still we are visiting O of n times only, or t you can say. So total column calculation, if we'll do, we compute the sum of the each element by visiting all the row of t times of n, you can say. So for the vertical cuts, we are iterating through n minus 1 columns, and we are computing the prefix sum, and for O of n times. So if you'll compute all of these, right, so just for the checking, we are taking O of t, O of t, O of t, and then we are doing O of n, and it is proportionally equal to m into n, right? And since it is efficient, right, and so we can say this is the time complexity. If we talk about the space complexity, no extra spaces we have used, right? We are using O of n space, right? Just using the variables, right? And we are storing the column sum. So we'll take O of n space to store the column sums, and other variables are constant. So total space we will talk about O of n times, and it is also efficient. So thank you guys. Thank you for watching this video. I hope you like this video, and please subscribe this channel.